Well, we will begin today's lesson as we've been doing the last few times with a mixed review. Before we get into section 5.7 with scatter plots and trend lines, I would like you to pause and go ahead and try in your notes to complete 1 and 2 there, just reviewing some things that we've already covered in class, and then unpause and you can check your answers to see how you did. So I'll give you a minute to do that. So pause now. So hopefully you had a chance to do 1 and 2. Remember when it says slope intercept form, that's going to be y equals mx plus b. So I solved the slope by doing the formula. So change in the y over the change in the x, simplified to 3. And then I used the slope intercept form formula and plugged in the first point for x and y and plugged in my slope for m. So that way I can solve for my b, my y-intercept. So I subtract the 3, so b should be -2. So my equation will be y equals 3x minus 2. And then we talked the other day about slope and perpendicular lines. The slope for a perpendicular line, they have to be opposite reciprocals. So in this case, the opposite reciprocal of -4 is 1/4. So just be aware that just reviewing some of those concepts there. So today the topic is scatter plots and trend lines. I'm obviously not going to read through everything here, but it does have some good information, so I'll just do some quick highlights. So a scatter plot is a graph that relates two different sets of data by displaying them as ordered pairs. A scatter plot can show a trend line or what we call a correlation, which may be, as we can see here, it can be a positive correlation, a negative correlation, or you can see no pattern. So there's no correlation. Generally, a positive relationship is going to be moving in this direction. A negative correlation looks something like this. And then here we have just a random set of points. So you can use a trend line to estimate a value between this set of data. It's a way to predict what might happen. There's some vocabulary here, words as well. Interpolation is estimating a value between two known points, two known values. And extrapolation is predicting a value that's outside of the range of known values. So something in the future that really hasn't been collected yet. In this first problem here, it's again worked out for us a little bit. They have a table here comparing the average height of girls at different ages. They want us to make a scatter plot of the data and then identify what type of correlation the scatter plot indicates. So they plotted the points in the table, and we notice that in general, as height increases, as age increases. So we can say that this data has a positive correlation. A trend line, in this case, would be a line that we could draw on the scatter plot that is near or through some of the points. And then we can use this trend line to estimate other values. We can actually come up with an equation for that trend line. And we're going to be spending a few days on this idea, so it is something that we'll get practice with throughout the next few days. So if we look here at example 1, we're going to be making a scatter plot, and we're going to be describing its correlation. So I want you right now to go ahead and make a scatter plot of the data in this table. And then we're going to talk about what type of relationship do we see. So go ahead and pause here. Go ahead and make your scatter plot, and then when you unpause, we'll continue on. So as you can see, after you've kind of estimated where those points go, we have made a scatter plot, and I should say here this was gallons bought. We want to know what type of relationship does this scatter plot show. Well, in general, the data seems to be increasing over time. So because it follows that general pattern, we would say this has a positive correlation. So just looking at that general trend there in number 1. So let's go on to another example. So here is the same growth chart for girls that we saw a minute ago. And now it wants us to draw a trend line for this scatter plot. It also wants to know what is the equation of this trend line. And then we could use that equation to estimate the average height of a girl who, let's say, is 12 years old. So if we look here, we're going to draw a line that seems to fit the data. So in general, that line does not have to go through every point, but it needs to go through the middle of the data, through some of the points if possible. But it doesn't necessarily have to go through any. It just needs to go in the middle and follow the trend. So here they already drew a trend line as an example. Notice it doesn't go through every point exactly, and it won't, but it shows that relationship and tries to hit most of the points if that's possible. So you will start by drawing a line that seems to fit the data. The line drawn for this data goes through, they picked 2 points. So this line goes exactly through 440. So they're going to use that point, and it goes exactly through 850. So we're going to use those 2 points to write an equation of the line. So using those 2 points, we find our slope, and then we can use point slope form and pick one of those points to plug into our point slope form and simplify so it's in slope intercept form. Then we can now use this equation to estimate or predict the average height of a 12-year-old girl. So we would plug in 12 for x, and we would get an answer of 60. And I'm assuming this is in inches, although they didn't really say here, or at least I missed it. I guess if I go back, yeah, height in inches. There we go. So if we look here at problem number 2, we are going to make a scatter plot of this data. We're looking at body length of a panda. And then I want you to draw a trend line and write its equation. Now, this is where it gets kind of weird because everybody could draw a slightly different trend line. Everybody could then pick slightly different points, so their equations will be slightly different, and that's okay. So just be aware that not everybody's going to have the same exact equation for their trend lines. Just know that up front. So why don't we pause again, go ahead and graph the points and make your trend line. Go ahead and practice writing your equation for that trend line, and then unpause and you can kind of see an example of what I did, okay? So you can see here, this is an example of my trend line. yours may be different, and that's okay. They're all going to be a little bit different. So what I did was I plotted each of the points in the table, and I tried to draw a trend line through the middle or close to the data points. Then I chose 2 points that my line goes directly through. Then I used those 2 points to find my slope. I went ahead and changed the slope to a fraction, and then I plugged that and my first point into point slope form, and they wanted to know what was the approximate body length of a 7-month-old. So I went ahead and plugged in 7 for X here, and I got an answer of 23 and 12/14 inches, which if you check at 7 months here, if I went across to about where 23 is, I'm really close to my trend line. So I know that my answer makes sense, and it seems to follow where it should follow in the pattern. So moving on to example 3, we can find the line of best fit. So for data of tuition and fees charged at public four-year colleges, the equation of the line of best fit is given here. And these equations can be, These equations can be pretty messy, meaning they're not going to be like nice whole numbers and things like that. So it tells us X equals the year at the beginning of the academic year, and Y equals the cost. So they want us to predict the cost of attending a public four-year college if it was 2016, 2017, just some kind of random year using this equation. So X represents the year at the beginning, so that means 2016. So we would plug that into the equation for X and solve that. So I'm going to go ahead and do that real quick, and then I'll be right back with the solution. So as we see here, when I plugged 2016 in for X, I ended up with $9,964.17. So that would predict the cost if it was the year 2016. Of course, we could put in the year that you start college, and that number would probably, of course, be higher. So that also, it just includes tuition. So think about the extra costs. If you're going to stay in a dorm, you obviously have to have books for your classes, which can be very expensive, even online books. So there's a lot more cost, but this is just for a public four-year college. That's not even for a private four-year college. And that was several years ago also. Okay, so I'm going to stop here because I'm going to run out of time, and then I'll make another short little video to finish up with this last example. I think it's the last one, and then you will have time to work on your worksheet. Okay?